Okay, in the last video, we talked about using the normal curve to figure out the probabilities of certain things. Well, if we're using just the normal curve, we really have to stick with those z-scores of 1 and 2 and 3, or -1, -2, -3. We don't really have values for things like 1.5. So what we're going to do in this video is we're going to talk about how do we do scores for things that aren't those pretty 1, 2, and 3 numbers, and we're going to use what we call the unit normal table. So just kind of to show you how to use the unit normal table, we're going to start with the positive values first, and we'll talk about both positive and negative because we do it a little bit different for each one. So for a positive, we're going to find the z-score in the first column. Now this is a very shortened version of your normal table. You probably want to print out a full normal table for you to use while you're doing your homework. There's actually one built into it, but sometimes it's better just to have the printed out one. It makes it a little easier to read. So again, we're in that first column, we're going to figure out what our find our z-score. Then we're going to have to determine what area we need. So here's the rule. If we say that we want z-scores less than, we're going to use the first, or the column B, the proportion in the body. If we want to say that we want to know percentages or probability of it more than whatever our z-score is, we're going to use the second, or I guess technically the third column, that proportion in the tail, or the column C. And then if we want to know between the mean and the z-score, that would be column D. Okay, and then let's say we want to find the probability that a randomly selected z-score would be less than 0.30. So what we want to do, again, we want to say less than. Less than is the body of the thing, so we're going to use our column B to do that. So we're going to find 0.3 first, or 0.30. That's going to be right here on our chart. And then we're going to look in column B, and the probability that something would be less than 0.30 on our z-score is going to be 0.6179, or if we multiply by 100%, be 61.79%. So there's a 61.79% that somebody's score would be below a z-score of 0.3. Okay, so what if it happens to be a negative value instead of a positive value? So what's going to happen is we're actually going to end up switching our proportion, the body and the tail of this problem. So we're still going to find the z-score in the first column, ignoring the negative. Okay, so you'll just find the positive value of the z-score, whatever it happens to be. Now what happens is that if you say you want it to be more than, you're going to use column B. If you want it to be less than, you're going to use column C, and then column 3 is always the value between the two. So basically, your body and your tail switch places as far as which one is more than and which one is less than. Okay, so if we look at this, we want to find the probability that a randomly selected z-score is more than -0.27. So again, the first thing we're going to do is we're going to find 0.27 positive value on our chart. So there's that 0.27. And then because we're saying we want it to be more than for this is going to be the body, which is our column B. And we can find that the probability that Z is greater than or more than -0.27 is going to be 0.6064, which is 60.64%. Okay, and I have a couple more examples of this, so if you're kind of like looking at this going, oh, I'm not 100% sure, I've got 3 more examples to do with you guys to make sure we understand how to read the chart. Okay, now one thing that I think would be very beneficial, and this is another reason why I would suggest printing this out. You can, if you can't find a printout of it, just let me know and I'll send one to you. But at the top of it, for me personally, I would add this extra information. So I would say, well, if my positive Z, then B, column B is less than, column C is more than, column D is between. If my Z is negative, then column B is more than, column C is less than, and column D is between. So that it's right there for you, and it's much easier. You don't have to look at the pictures or guess at it when you're doing these problems. So again, looking at the first one, we want the probability that a score is more than 0.23. So remember, we're going to find 0.23 first on our column A, and then because we want to do more than, and this is a positive z-score, we're going to use column C. So if we get those two, we find that the probability of being greater than 0.23 would be 40.90%. All right, so let's look at the next one. The next one says find the probability that a randomly selected value would be more than negative 0.29. So this is a negative value. So when we find this, we're still going to find 0.29, but this time because we want a more than of a negative value, we're going to use column B to figure that out. So again, finding the 2.9 first, or 0.29 first, and then using column B. And we say that the probability of z being greater than negative 0.29 would be 0.6141 or 61.41%. Okay, and then the last example here, we want the probability that a randomly selected z-score would be less than 0.34. So this is a positive z-score. We want to be less than, so again, we're going to use that column B since it's a positive and we want less than. So we're going to find 0.34 on our list and then use column B, see where those two intersect, and we get the probability of z being less than 0.34 as 0.6331 or 63.31%. If you have any questions on how to use the chart or are you confused by it, please just let me know and we can do some additional examples.